It's Don here from the board. Thanks for coming along and checking out this video. Today's video is a bit of an update in regards to what's been happening on my 3x3 Hotswap macro pad project. So in the last couple of weeks, as you would have seen from a previous video, I had actually managed to 3D print a case as well as the blanking pieces and the top plate and put them together. Now I don't actually have it with me for this video because it's actually at work. I've used it to demonstrate to people about the flexibility, the versatility, and what kind of things you can do with a Hotswap keyboard, and it's been pretty well received. However, as part of the initial design, the concept of the Hotswap was not just for the switches to be hot swappable using the Kale Hotswap sockets, but also for the microcontroller, the Pro Micro, to be hot swappable as well. And I was kind of missing a rather important piece to that puzzle, which was some kind of socket system. Now, I can't remember if I spoke about it previously in the other videos, but I know that from the 40% Club already, people have done Hotswap Pro Micros, but they've been using low profile sockets and they tend to be the round sockets. Now, yes, that's fine from an enthusiast's point of view, because the process is, you put tape down, you put the Pro Micro on, you stick diode legs through it, you solder it, and then you clip it, trim it, and so on and so forth. But from a larger scale point of view, it's probably not as feasible if you're trying to build units or manufacture units for ease, simply because you don't want to have to go to that hassle, especially if you're going to be doing a lot of them for a large number of people. So I dug around, I contacted some suppliers locally, and they were like, yeah, we can get sockets down to a certain size, but they tend not to be very popular, so we don't stock them. I had one person say, I can get you samples, and then I never heard from them for a very long time. So I just went, you know what, stuff it. I'm just going to go and get a standard female hot socket simply because I wanted to advance the progress of the project. And by doing so, the only difference between what I was trying to find, which was a low profile socket, to what you can get readily and easily is just simply the height. So what I've got here in front of me is just a standard, I think it's 8.4, 8.6 mil female header with a 2.54 millimeter pitch. So that's the actual spacing in between. And I had been led to believe that it shouldn't be an issue and it should be fully compatible and usable with a Pro Micro, but this is essentially now what we're going to be testing and checking out and seeing what kind of things we can do with it. So let's switch over to the desktop and check out what is going on. Okay, there we go. So I've got some tools with me. I've got one of these strips. I've got a blank PCB that I haven't built yet. I've got a Pro Micro that I can use for testing and some tape and something to put bits and pieces on as I need to. Now this strip was a purchase from AliExpress. Yes, I probably could have bought it locally and much easier, but quicker probably not. More expensive, definitely. So JCar here sells these for about $1.70 each per 40 pin strip. This is a 40 pin by 1, so it's just a single row. You can get double rows, but obviously double rows won't fit a standard footprint. $1.70 doesn't sound like a lot, but then of course I would have to get myself to a JCar to pick one up. Otherwise I would pay post, and then post makes it a lot more expensive. I went on AliExpress and I managed to buy 100 of them from AliExpress, including expedited post, for $15. So these are 15 cents each. Am I going to use 100 of them? I don't know. Maybe if my work project does, ramp up significantly. If not, I can literally hot socket, potentially, every single one of my Pro Micro builds from here on in for a very long time. Now, so the whole concept is that this will somehow connect to this, and then the Pro Micro will go into the back of this. Of course, 40 is way too long for a particular single, and you can buy shorter ones in smaller amounts, but you can also cut these down, and that's what I'll be having a play with right now in this video. As you'll notice, I don't have any of my soldering set up in this video because I don't plan to actually do the soldering part yet. Just got home from work, and you know, my daughter's out there watching Play School at the moment, so I thought I'd take the time to do the video instead rather than the building. So first of all, let's just check out how it integrates in regards to a Pro Micro, at least one side of it, or the theory of that anyway. Let's take off the tape I put on previously so I didn't lose my bits and pieces. Okay, so there's the Pro Micro, pretty standard. This is the blue one. Then I've got my standard pins that come with it in each packet. I'm only going to need 1/2, of course. And you'll see there's the actual female side. And, well, short side, it goes in and it fits, but I don't know how well it's going to hold electrically or not. Now, I hear footsteps and a pitter-patter, and there you are. Hello. Do you want to be on Daddy's video? No. So she's trying to check out what's going on up here. So what I do have here is my multimeter, my trusty cheapy multimeter. So I've got the short side socketed in, but you'll notice it's actually at an angle. It's kind of tilting at an angle. It's not sitting straight. And that's because the pins aren't actually very deep. They're not going in and contacting very well or consistently. So I can feel that it's clicking against something in there. To be honest, I don't think there's much point. Yes, there's contact. Is it going to be good contact? No. So of course we flip that around and it's much longer. There's resistance right there at that depth. And once I give that a push, there it is. It seats really well. So, and I'm pretty confident that should have good connectivity, but of course, for the sake of completeness and science, here we go. There's resistance. My probes, you can see it goes down to below 0.1, about 0.05. So against the contacts here, and contact there, and we have connectivity. So it's pretty good. Alright, so that passes the first test. Now, naturally, you can just do this to it, which would be sort of the standard way of actually using it as intended. So the short side through the PCB, right? Of course, there's enough poking through that you can just solder it in from the top. But how much connectivity and how much holding strength would I get if I had a bit of fun and I put it through the long side? Because you'll see there's still heaps of pin length here. Okay. You can see there's a bit of resistance there, but now if I'm just going to push it through, it's now engaged by the actual holding of the trident inside here as well. I can hold it upside down, I can sort of shake it, it's not falling out, and well, we're about to find out what the connectivity is like here as well. So let's just put it between the first two, and it's good. So we can see there's definitely good solid contact here, and this is where I'll be interested to see what the capability of going through the holes is like. And I'm going to say straight off the bat, I don't think it's going to work very well because it's not soldered. The pads are only going to be, if at all, lightly touching. So you still will need to do some kind of soldering. But the difference is, right, if you can somehow solder across the top, or even jack this in to these headers, right? Yep. And then take off that black bit, because you can, right? You can actually do that and solder it through the top. Well, you've reduced the amount of height that you have to deal with by the height of that black plastic bit on those header pins. So it's just something to think about. And I'll show you what I mean in that these pins with enough force. Probably shouldn't do this, but probably will just snap this one off. Oh. There we go. They push right through. So they're only held in there by friction. Now it's not focusing very well, but you can kind of see the point there. So there's nothing actually stopping you from being able to socket it and then, well, heck, let's just see how far this will go, because now that I've actually pushed that all the way, there's some serious depth on that. Look at that. That length of that pin goes all the way through. So if I take that and go all the way in, will I hit bottom? Yeah. Okay, so I've hit bottom. So I could actually pull out every single one of these headers, slot them in, drop the Pro Micro on top, and then solder it into the top of the Pro Micro. And then now I've actually got a Pro Micro with a header that still works without that black bit, and I've managed to reduce the height profile as well. So there's a couple of things that I can play with here in regards to when I get around to actually soldering this together and building it. So they're just some of the things to think about if you were to ever go down a path of creating a hot swap with a Pro Micro using a standard header. Now if you were to use a shorter header, then once again there are also things to consider. Now I did some sort of Googling to see how one would actually trim these down and cut them to length, because it's quite common practice. So I've been led to believe, and there's two ways that people do it. They either use a nibbler or they do the score and snap method. So I'm actually going to do both, because I need to break two sections off. The first thing that people advise you to do is count the pins, and then you need to pull out the pin in between the section that you want to break off. So these are 12s, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you want to grab the 13th pin, because you need to pull that pin out. So of course I'm just going to double check that I have a pin lining up against every one of those, and yoink. And it's just like this tiny little trident. The video that I watched was pretty good. Somebody had a good sense of humor, and they were talking about what you could do with this tiny little golden trident. But I don't have any jokes, so I'm just going to put that aside. Don't know what I'm going to do with it afterwards. But so now you've got that gap in that row of pins, and essentially you want to score and snap. Now of course I could get this nibbler and I could feed it through and I could start breaking it, but I'm going to go with the score and snap first. So what I did come up with for my own assistance was actually marking the channel, because you don't want to be breaking off the wrong section at all, and you want to score the right place, because if you score the wrong place you're going to have a bad time. Okay, so I've just marked that edge with the tape so I know where I'm going to be scoring against. I don't have a metal ruler, so let's just use the edge of my PCB here to guide me, and just lightly score it a couple of times, and then I'm going to flip that over. Okay, so I've scored it on both sides, and now comes the moment of truth where I'm going to flex it and snap. Okay, so it was a pretty clean break. Camera's probably not going to focus it very well. Oh, there we go, reasonable. And yeah, I didn't snap it in the wrong place at all. I can peel the tape off, and now on my pins, there we go. So it fits. It's got quite a lot of height on that. I will say it has an awful lot of height. So once you actually put a Pro Micro on it, then it's going to get even more. But that's the price you pay for having a hot swap, unless if you get the lower height headers. Now the camera's not cooperating very well. There we go. Hold it up at that high angle. So that's the height that you're going to be looking at. But of course, if you design your Pro Micro and your pin and layouts and stuff like that, and you can flip it on the inside, then that bottom side will be, of course, even flatter. So it's just some design considerations to think about. And what you would do is you can also use your nibbling tool, and you can basically just clean up that broken edge if you want to. Now, I'm not too fussed. For me, that open edge is not a big deal. So now let's go again. We will need to identify where our 13th pin is. I can this time naturally just get one of these and line it up, because that's how many I want. Grab that 13th pin. Make sure it's good, and yoink, another little tiny trident. It's not really a trident, it's just a fork. It's almost like a musical tuning fork. So now that I've got the gap there, this time I'm going to use the nibbler. So the advice is you get one edge on the bottom, you get one edge on the top, and you're meant to do like that was a really wonky score. I don't think this method works so well, because I can't really get any purchase in that plastic. Yeah, it's quite messy actually, to be honest. Probably shouldn't be doing it like this, but yeah, I'm going to say that the score and snap method is much better compared to this one. I'm going to salvage that by using a score and snap. Ugh. Definitely don't do it that other way. I don't know how they did it, but not working for me. Okay. And hopefully that will be good. Okay, snap, and hopefully that'll be 12 pins matching as well. Right, so now I have 12 and 12. If I sit that like so, then I can put that through it, put that through it, and we can see what kind of monstrosity I have. Now you might say this is just stupid because it's going to be like crazy high. Well, yes, you would be right. It is going to be crazy high. Does it look stupid? Probably. But there it is. That is a hot swapped Pro Micro in all of its glory. And this is exactly why I wanted a much shorter female header, but you know what? At the end of the day, if I made a case that had that, it's actually got a really nice angle to it. So, you know what? I'm actually okay with that. It has a natural lift and tilt to it. Just trying to think, how can I show what that looks like without things being a little bit silly, but you'll just have to imagine what a flat object. There we go. So there we go. So there we go. It's got a good angle to it, and a case built around that probably wouldn't be the worst in the world. And at least it keeps your USB cable closer to the table surface anyway, so it's not hanging by that mini socket as much, micro socket as much. Now I'm kind of running away with my words. So there you go. That is what you can do with a 40 strip of hot swaps. Now I will have a little bit of leftover because it's 40 and 3 12s is 36 with 4 left over, but you're going to be yanking out 2 of them to snap it off, so you will get a little bit of wastage. But what it does mean is, you know, out of 2 strips, you can actually do 3 Pro Micros with them, because you're going to get 6 sets of 12 out of each dual. Right, that's pretty much it. That's all I've got for today. Hope to have some time soon that I can actually put this together and actually solder it in one of those configs, and then we'll see how it turns out and works. And then back to the drawing board to modify my 3D printed case, give it a bit more lift, give it a bit more angle, and then the dream of having a Hotswap microcontroller will come alive a little bit more. So there you have it. Thank you, of course, for coming along and checking out that video. Muchly appreciate it. And we are about, I think, 1946 subscribers, something like that. I know I've been saying it for ages, but it's still true. It's still going to happen. When we hit 2,000 subscribers, we're going to do that giveaway for the 2 COS keycap artisans that I've got right here. So yeah, if you're new to the community and you feel like it, please hit like, please hit share, please hit subscribe. And shout out to all our Patreon supporters. Thank you very much for making what we do possible as well. So enough babbling for me. Of course, as usual, until next time, happy clacking.